that made headlines around the world. The brightest minds of artificial intelligence converged on Asilomar, and a reporter asked them a question. When will this fabled singularity take place? When will the machines take over? When will machines become smarter than us? Well, the answer was quite interesting. Among the top people assembled in one place, the answers were anything from 20 years in the future to 1,000 years in the future, with some AI experts saying never. Some people put it at 2029. They even give you an exact date. 2029, that's going to be the moment of truth, that one day a robot will wake up in the laboratory, look around, and say, I am aware. I'm just as smart as you. In fact, I could be even smarter if I put a few more chips in my brain. Other people say, not so fast, not so fast, because Moore's law is going to break down. The reason why many people are so confident about this prediction of the so-called singularity is because of Moore's law. That computer power doubles every 18 months, and it's a curve that has held sway for 50 years. If you go back 100 years, back to the time of mechanical hand crank computers, put that into Moore's law, and you still get a nice fit. So believe it or not, Moore's law has been in operation for about 100 years, going back to hand crank calculators, with computer power doubling every 18 months. Well, can this go on forever? And the answer is no, because eventually physics takes over. And that is, physics says that silicon is unstable at the molecular level. Transistors get so small, so powerful, and they generate so much heat that the silicon chip melts and electrons leak out because of the Heisenberg uncertainty principle. You don't know where the electron is anymore. Therefore, we physicists are looking for replacements for silicon. The post-silicon era will be about 10 to 15 years in the future. Silicon Valley could become a rust belt. Think about it. Every Christmas, your PCs, your computers, your gadgets will be just as powerful as they were the previous year. And then the question is, are you going to buy? Are you going to buy any more computer products for Christmas time, knowing that they're just as powerful as they were the previous year? Probably not. Which means that the computer industry could begin to shake as a consequence. So we physicists are looking at optical computers, quantum computers, DNA computers, protein computers, all sorts of different kinds of architecture, down to the molecular, down to the atomic, down to the microscopic realm. But none of them are ready for prime time yet. So my answer is, I don't know. All I'm saying is there's vast uncertainties in projecting Moore's law into the future. However, I would say by end of the century, it is definitely conceivable that if we work out the technical problems, we might be able to create machines that are as smart as us. Right now, our machines are as smart as insects. Eventually, they'll be smart as mice. After that, they'll be smart as dogs and cats. Probably by the end of the century, who knows, they'll be as smart as monkeys. At that point, they could be potentially dangerous, because monkeys can formulate their own plans. They don't have to listen to you. They can formulate their own strategies, their own goals. And I would say, therefore, at that point, let's put a chip in their brain to shut them off if they get murderous thoughts. Isaac Asimov advocated something like that with his 3 laws. I say, hey, put a chip in their brain to shut them off if they start to upon the very heart of the quantum theory. In Newton's theory, the theory proposed 300 years ago, a dot represents matter, and it's just a dot. That's all it is. These dots can reform, collide with each other, obey certain equations, but they don't vibrate. Then in 1925, along came quantum mechanics, which says that these dots of matter, the electron, the proton, are not really dots at all. In some sense, they're waves, waves of vibration. Things are waving, and this means that our bodies are actually waving as well. This is the basis of wave mechanics, the fact that particles have wave-like properties. Then the embarrassing question is, what is waving? What is it that is waving? The answer is, and you're not going to like this, the answer is that what is waving is the probability of finding that particle at a given point. So let's now summarize it in one sentence. According to the quantum theory, matter is made out of dots, but the probability of finding the dot at any given point in space and time is given by a wave. Now, then you raise a question. What happens if you change the vibrations of these waves? Can you then drift into other universes? Can you then drift into other planes of existence? And at the atomic scale, the answer is yes. It turns out that waves can split. At certain key junctures, like an ocean wave, can hit a barrier, and then we have two ocean waves. So it is possible that quantum events can actually split universes apart, separated by probability. A 50% probability of this happening or that happening. So let's take, for example, Hitler's mother. Let's say a cosmic ray went through Hitler's mother. A cosmic ray is a quantum event. There's, let's say, a 50-50 chance that Hitler's mother will then have an abortion. Have a spontaneous abortion, a miscarriage. And a 50% probability that she won't have a spontaneous abortion, that she will have a full-term child, Adolf Hitler. So we now have the fact that because everything vibrates, two universes have now separated, and one universe has no World War II. All of a sudden, 60 million people didn't have to die, while the other universe is our universe. Now, this sounds like science fiction, right? The only difference between this and science fiction is that the scenario I've given you comes from modern physics. This is the basis of our present-day industrial revolution. Think of transistors. Think of GPS, the internet, television, radio, all the wonders of modern technology. They're all based on the idea that electrons are waves. And these waves, in turn, are waves of probability. And the probability can bifurcate, can fission, and universes can then emerge from other universes. So when I look at myself in a mirror, well, most people would say, I see me in the mirror. Well, I don't look at it that way. First of all, when I look at myself in a mirror, I say to myself, I'm looking at myself as I was a billionth of a second ago, because that's the time it takes for light to go from my face to the mirror and back. I'm not really looking at me at all. I'm looking at me as I was a billionth of a second ago in the past. Second of all, I'm not really well defined. I'm really a mixture of different kinds of waves. Now, these waves really do look like me. If I were to get graph paper and graph these waves, by golly, they really do look like me, except for one crucial difference. Parts of the wave ooze off. It's a wave. It oozes off to Mars, to Jupiter, to outer space. Parts of me ooze in all directions. So there's a finite probability that I will go to bed tonight and wake up on Mars tomorrow. Now, of course, it's a very small probability. I can calculate it. I would have to wait longer than the lifetime of the universe for that to happen. So chances are I'm not going to wind up on Mars tomorrow. However, it is possible. And I can even calculate the probability that I will wake up on Mars tomorrow. So anyway, to answer your question, A, everything is vibrating. B, these vibrations are vibrations of probability. C, universes do separate. Universes do separate and do all sorts of crazy things. But in the main, they average out. So when I look at myself in the mirror, on average, that is me. But that's only an average. Part of me is on Mars today. And part of you is also on Mars. Looking at the next 100 years, that there are two trends in the world today. The first trend is toward what we call a type 1 civilization, a planetary civilization, a civilization that resembles something out of Buck Rogers or Flash Gordon. A type 2 civilization is stellar. They consume so much energy, they can play with stars. That's, for example, the Federation of Planets in Star Trek. Star Trek would represent a typical type 2 civilization. Then we have type 3, which is galactic, like the Borg, or Independence Day, or the Empire of The Empire Strikes Back. That is a type 3 civilization, which is truly galactic. Now, By the time you reach type 2, you are immortal. Nothing known to science can destroy a type 2 civilization. Comets, meteors, earthquakes, even a supernova. A type 2 civilization would be able to survive even a supernova. The danger is the transition between type 0 and type 1. And that's where we are today. We are a type 0 civilization. We get our energy from dead plants, oil, and coal. But if you get a calculator, you can calculate when we will attain type 1 status. The answer is, in about 100 years, we will become planetary. We'll be able to harness all the energy output of the planet Earth. We'll play with the weather, earthquakes, volcanoes, anything planetary we will play with. The danger period is now, because we still have the savagery. We still have all the passions. We have all the sectarian fundamentalist ideas circulating around, but we also have nuclear weapons. We have chemical, biological weapons capable of wiping out life on Earth. So I see two trends in the world today. The first trend is toward a multicultural, scientific, tolerant society. And everywhere I go, I see aspects of that birth. For example, what is the internet? Many people have written about the internet, billions and billions of words written about the internet, but to me as a physicist, the internet is the beginning of a type 1 telephone system, a planetary telephone system. So we're privileged to be alive to witness the birth of type 1 technology, a planetary telephone system. What is English? English is the beginning of a type 1 language. Everywhere I go around the earth, people speak English because that's the lingua franca of science, technology, business. They all speak English. It is the #1 second language on the planet Earth. And what is the European Union? The European Union is the beginning of a type 1 economy. And how come these European countries, which have slaughtered each other ever since the ice melted 10,000 years ago, how come they have banded together, put aside their differences to create the European Union? Well, to compete with us. And who are we? We are NAFTA. So we're beginning to see the beginning of a type 1 economy as well. Then we're beginning to see the beginning of a type 1 culture. Everywhere I go, you turn on the radio, and what do you hear? Rock and roll. You hear rap music. You hear youth music. Youth music is now planetary, knows no boundaries around the planet Earth. Everywhere I go, I see high fashion. Chanel, Gucci bags. We're witnessing the birth of a planetary fashion. Also sports. Take a look at the Olympics. Take a look at soccer. We're seeing the beginning of a tribal initiation rite called sports being turned into a planetary initiation rite that unifies the entire planet. So whenever I open the newspaper, every headline I see in the newspaper points to the birth pangs of a type 1 civilization in formation. However, every time I open the newspaper, I also see the opposite trend as well. What is terrorism? Terrorism, in some sense, is a reaction against the creation of a type 1 civilization. Now, most terrorists cannot articulate this. They don't even know what the hell I'm talking about. But what they're reacting to is not modernism. What they're reacting to is the fact that we're headed toward a multicultural, tolerant, scientific society. And that's what they don't want. They don't want science. They want a theocracy. They don't want multiculturalism. They want monoculturalism. So instinctively, they don't like the march toward a type 1 civilization. Now, which tendency will win? I don't know. But I hope that we emerge as a type 1 civilization. Now, in outer space, we look for signs of intelligent life in outer space. So far, we find none. Civilizations like type 1 should be commonplace in the galaxy. Some people assume, therefore, that type 0 civilizations are rather common, but only a few of them make it to type 1, because that society, for the first time in its history, has the ability to commit planetary suicide. So maybe that's the reason why we don't see aliens in outer space. Maybe they never made it. Maybe one day when we have starships and visit them, we'll see atmospheres that are irradiated because they had a nuclear war. atmosphere is too hot to sustain life because they had a runaway greenhouse effect. Maybe when we go in outer space, we'll see the corpses of type 1 civilizations that never quite made it. That's yet another very embarrassing question. Believe it or not, even though tens of thousands of papers have been written about consciousness in the literature, nobody has a suitable definition for consciousness. What does it mean to be conscious, and how do you encode it? And what is the minimum amount of consciousness necessary to animate something else? This raises questions for artificial intelligence, because some people in the field of AI believe that one day we will be immortal. We will live forever. But the question is, what will live forever? The atoms that make up our body, they give us consciousness, they give rise to our personality and our fears and desires, that may die. But yet the essence of the neural circuits may survive. Now, there are many ways to do this, so let's break some of them down. The most ambitious has been proposed by people who believe that one day we will create a robot body that is perfect, a Superman, beautiful, elegant, super powerful body with no brain. Then we will start to extract our brain tissue, neuron for neuron, and duplicate it with transistors. So for every neuron we take out of our brain, we replace it with a transistor. Sooner or later, chunks of our brain are removed and inserted transistor for transistor inside this robot body. Now, we're fully conscious during this process. Part of our brain computes here, and part of our brain computes over there, connected by wires. Well, after a few hours, large portions of the brain are gutted, and huge chunks of transistors are added to this robot of silicon and steel. And when it's finally finished, you now have no brain in your head, and here's a robot with a complete brain and a complete body. That's one of the most ambitious ways to transfer consciousness from our body to another body. And then the question is that really you? Well, there's another way to do it, and that way was explored in The Sixth Day with Arnold Schwarzenegger. In that movie, the bad guys get killed, but each bad guy was cloned, and somebody was able to somehow photograph all the memories of our brain and insert these memories into the clone. Now, we don't know how to do that, obviously. That's way beyond our technology. So don't expect Arnold Schwarzenegger to come back fully formed with all his memories as a clone. That's not going to happen anytime soon. However, the initial steps are, once again, being made. At Caltech, for example, they've been able to take a mouse brain and look at a certain part of the brain where memories are processed. Memories are processed at the very center of our brain, and they've been able to duplicate the functions of that with a chip. So again, this does not mean that we can encode memories with a chip, but it does mean that we've been able to take the information storage of a mouse brain and have a silicon chip duplicate those functions. And so was mouse consciousness created in the process? I don't know. I don't know whether a mouse is conscious or not, but it does mean that at least in principle, maybe it's possible to transfer our consciousness and at some point maybe even become. Here's a theory, David, about what dark matter is. You talk about different universes. Let's say that our universe is a sheet of paper. We live our entire life on this sheet of paper, but directly above us, there could be a parallel universe hovering right over us, perhaps inches, centimeters away, and objects in this parallel universe would be invisible. Light travels beneath the universe, so we never see this other galaxy. But gravity goes between universes, because gravity is nothing but the bending of space. So if the space between two sheets of paper is bent slightly, gravity then moves across. So think about it. This other galaxy in another universe would be invisible, yet it would have mass. That's exactly what dark matter is. Dark matter is massive, it has gravity, but it's invisible. It has no interactions with light or the electromagnetic force. So there is a theory that says that perhaps dark matter is nothing but matter, ordinary matter in another dimension hovering right above us. We should also point out, however, that there are other theories too. Dark matter is the cutting edge of science. Some people think that maybe it's a higher vibration of the string. All the atoms of our body represent the lowest octave of a tiny rubber band vibrating all over our body. And the rubber band can have a higher octave. That next octave could be dark matter. So that's yet another explanation for what dark matter might be. So the bottom line is this. There's a shelf full of Nobel Prizes waiting for you, waiting for anyone who can come up with a convincing and experimentally verified explanation of the origin of dark matter.